Okay, 8.1, average value of a function. Okay, so it says recall the intermediate value theorem. Okay, so I'm going to draw what that graph looks like. Okay, so recall that intermediate value theorem, or IVT, states that if we have f, which is continuous, and f of a greater than f of b, this implies that there exists some c value such that c is between b and a, and f of c is between f of b and f of a. So pretty much on this continuous function between b and a, there's going to exist some point c. We know that because it's a continuous function, there is no discontinuities in between those 2 points. Okay, also recall we talked about average rate of change. That's f of b minus f of a is divided by b minus a. So we called that AROC, average rate of change. And then we had the mean value theorem, NVT, that said f prime of c is equal to f of b minus f of a over b minus a. And then from the mean value theorem, we learned that the instantaneous rate of change is equal to the average rate of change. Okay, recall those problems when we were doing applications of derivatives, where we would set these two together and find some k value that made it true. Okay. Now we're talking about average value of a function. So the average value of a function on the closed interval AB is 1 over b minus a times the integral a to b f of x dx. So ultimately, when it's asking us to find the average value of a function, we're going to be plugging in our information into this definition, taking the integral, and then simplifying. So number 1 says, find the average value of f of x equal to 6 minus x squared on the closed interval -1 to 3. So this is our a, this is our b, and I'm just going to plug it into the formula above. So I have 1 over 3 minus a -1 times the integral of -1 to 3 of f of x, which was 6 minus x squared, dx. Okay. We can easily integrate this by giving us what? What would be the integration of 6?
6x.
6x. And what's the integration of -x squared? Good, -x cubed over 3. So simplifying that fraction right before, we have 1 over 3 minus a -1. So that's 1/4. Okay, and then we just said this is 6x minus 1/3 x cubed. And we're going to solve this at -1 to 3. Okay, so first I'm going to plug in 3. So I have 1/4 times 6 times 3 minus 1/3 times 3 cubed minus, and then I plug in the -1. 6 times -1 minus 1/3 times -1 cubed. Okay, so simplifying this, we get 11/3. Some magic of algebra. Okay, but in this case, you'll have decimals, right? So technically, you could have just plugged in the integral in the beginning, and they would give you whatever 11/3 is as a decimal. Okay. So it says, when does the function assume this value? So in order to find this, we're going to set the function equal to 11/3. So 6 minus x squared is equal to 11/3. Okay. We would subtract the 6 over and then multiply everything by -1, and we get x squared is equal to 7/3. Okay, then we would take the square root of both sides, and we get x is equal to plus or minus the square root of 7/3. Okay, if we were to put that into the calculator and turn that into a decimal, we would notice that negative square root of 7/3 is outside of the closed interval -1 to 3, which means that value cannot represent the function when it's equal to 11/3. So that means we have just that x is equal to positive square root of 7/3. Okay, so if you want to off to the side, note that negative square root of 7/3, okay, is not included on the interval -1 to 3. Not included, I just used the math symbol that is a curly looking E, which means included, and I crossed it out, which means not included. Okay, then it says comparing average rate of change and average value of a function. So it says set up the equation for each question and use a calculator to solve it. So it says h of t is equal to -16t squared plus 41t plus 10, where h is the height in feet and t is the time in seconds. What is the average height during the first 3 seconds? Okay, so average height, that means we're going to be using the formula from above. And first 3 seconds tells us that this is the interval from 0 to 3. Okay, so I'm going to plug this in. So I have 1/3 minus 0 times the integral of 0 to 3 h of t. So -16t squared plus 41t plus 10 dt. Okay, and I can solve this by hand. But if we have the calculator, let's go ahead and just use it. So what I'm going to do on Desmos is I'm going to type in this entire part here, and I just need to make sure I include parentheses around my function so it works. Okay, I'm even going to put the fraction right in front of it as well. So 1 divided by 3 minus 0 is just 1/3. So going on to Desmos. Okay, so what I'm going to do is I'm going to type exactly what I have in. So I have 1 divided by 3. And then in order to do an integral, just type int. Okay, so int, and there's our integral. Okay, then we're going to do 0 to 3. And if you have your Desmos open, you should be following along on Desmos. Make sure you understand how to use Desmos in this instance. So t squared plus 41t plus 10 dt. Okay, and notice I get 23.5. And since this is including units, it'd be 23.5 feet. Okay, so I just plugged in exactly what I wrote on my paper into Desmos, and it did it for us. Okay. This is something that we could have easily integrated, however, because it's just a bunch of the power rule. Okay. It was 23.5? Okay, thank you. 23.5 feet. So again, we could have integrated this by hand, but if they give you access to Desmos, just go ahead and use it. B says, what is the average velocity during the first 3 seconds? Well, if they give us the function for height, then the function for velocity would mean we would have to take derivative. Good. So off to the side, I'm going to say, okay, well, velocity is equal to the derivative of height. So that means velocity is equal to negative 32t plus 41. Okay, I just took the derivative of that h of t function. Okay. Then I'm going to just run the integration like I did before. So first 3 seconds is still 0 to 3. So this is going to be 1 over 3 minus 0 times the integral of 0 to 3. And then our function, so negative 32t plus 41 dt. Okay, go ahead and take a minute and type that into your calculator. And then if you already got the answer, tell me what you got. -7. And what would be the unit since this is velocity? Feet per second. Okay, so notice we just used the average value of the function to solve this. However, we could have also used the average rate of change. Okay, so up to you if you want to include this on your note. Yes?
So how did you get the 32 and 41?
Because we took the derivative of h of t. So I got negative 32t from the derivative of negative 16t squared, and then 41 from the derivative of 41t. And then plus 10 went away because it's a constant. Derivative of a constant is a 0. So the reason we did that is because we wanted velocity. So let's actually write out the average rate of change formula here. So we know that is h of 3 minus h of 0. So that's f of b minus f of a over 3 minus 0. Well, if we were to plug that in, again, using Desmos, okay, plugging in 3 and then plugging in 0, we would actually notice that we get the same thing. We get -7 feet per second. Okay, so that is the connection between the two. Okay, so finding the average rate of change is the same as finding the average value of the function. Okay, especially if they give you the, if they want you to find the derivative of that function. Okay, so notice how instead of saying find the average height, we could not have used the average rate of change formula, but it was because we were finding the average velocity, which is the derivative of average height, we were able to do so. Any questions on 2? What I would do is I would just always just do this method. We're used to integration, just stick with integration. Okay, number 3 says r of x is equal to 2 times sine of x minus 1, where r is the rate at which Mr. Burst's waistline is changing inches per month, and x is time, which is months. It says, what is the average rate of change that Mr. Burst's waistline changes from the 10th to 12th month? So notice we are finding the average rate of change of r of x, which is already a rate, okay? So we're going to still use that same formula with the integral, and we're going to do 1 over b minus a. So this is from 10 to 12. So this is going to be 1 over 12 minus 10. Integral from 10 to 12, 2 sine x minus 1 dx. Okay, and then you're going to go ahead and put this on Desmos, but you need to make sure that your Desmos is in what? Radians. Okay, so again, if it's not in radians, does everyone know how to check that? Okay, if it's not in radians, you're going to get a completely different answer. So again, to check that, you would click on the little wrench on the top right. I'll go ahead and show you guys. Click on this wrench on the top right here. Make sure radians is shaded. Okay, and then of course you would go over here. And since I'm here, I'll just type it out. So 1 over 12 minus 10 is 1/2. So 1 divided by 2. Type in my integral from 10 to 12. Okay, 2 sine of x minus 1. And then dx, just make sure that this is in parentheses or it won't work. Okay, and notice I get negative 2.683 if I'm just rounding to those 3 decimal places. Okay. And since this is a rate of a rate, it's almost similar to when we were taking the velocity, right? So what would be the units in this case?
Inches per month.
Inches per month. So what does it mean by it being negative?
His waist is shrinking.
His waist is shrinking. Okay. So on average, his waist is decreasing by 2.683 inches per month.
Oh, okay. Skinny.
Yo, it's a side function, we'll back up eventually.
That's why they made it a sine function, yes. Okay, B says, what is the average change of this rate during the first 5 months? Okay, so average change of this rate. Well, that rate that they're talking about is R. Well, we can solve this by using the average rate of change formula. So again, this is just showing you back and forth that these two formulas are the same thing. So this is my f of b minus f of a. So it's first 5 months. So that is 0 to 5. Again, just plug this into Desmos. If you plug in the original equation r of x, on the next line, you can actually type in this entire fraction here, and it will give you negative 0.383. Okay. But since this is the average change of this rate, which was already looking at the average rate of the original rate, this is going to be inches per month squared. Or inches per month per month. Okay, both are correct. Inches per month squared.